In this video, I'm going to cover example number 6 to example number 10. Okay, now let's start with the example number 6. Find the square roots of. In this, we are having two questions. In that first one is 2, 7 by 9. Here it is mixed form. Now let's convert to the improper. For that, first we will multiply here. 9 to the 18. 18 plus 7. I'll get that is 25. 25 by 9, and this square root we need to find. Okay, 25 how we can write? We can write 5 raised to the power 2. Meanwhile 9 how we can write? We can write 3 raised to the power 2. Like 5 has a 25, 3 3 is a 9, and that's square root. Okay, now both powers are same, so we can take the common. So if I take 2, see, and this square root I am writing 1 by 2. 2 get cancels. What left? 5 by 3. This is what the this answers square root is 5 by 3. And but before this they have given the question in the mixed form. Now we will convert this improper to mixed. For that we need to divide 5 by 3. 3 ones are 3, subtract 2 left, right? Now this quotient comes in the whole number place, and this remainder comes in the numerator place, and the denominator we have to write this 3. 3 ones are 3, 3 plus 2 is 5 by 3. Okay, next question we have, that is 4.41. This square root we need to find, right? Now which is in the decimal, no, that we will convert to the fraction. So let me write 441. Okay, now see here how we can write to in the fraction form. Here in the digit place I'm writing 0 0, and in point place I'm writing 1, like by 100. Square root of 441 by 100. Now to find out the square root for these numbers, first we will have to find out the prime factorization method. Like 441, start from 3, 3 ones are 3, 1 left, 3 3 5s, no 3 4s are 12, 2 left, 3 7s are 21. Now 3 4s are 12, 2 left, 3 9s are 27. Now 7 7s are 49, 7 1s are 7. It means for 441 we got that is 3 raised to the power 2. Why? Because here it is in the pair, here it is in the pair, into 7 square. Okay, now for 100, see, 100, start from 2, 5s are 10, 0 as it is, 2 25s are 50. Okay, now start from 5, 5 5s are 25, 5 1s are 5. Now here it is we got in the pair. Now 2 square into 5 square of that square root. Okay, now see here all over the we are having the power 2, so we can take the common. So what left? 3 into 7 by 2 into 5. This I'm just putting it in the bracket, and on that raised to the power 2, and this square root we can write 1 by 2, right? This 2 to get cancelled. So what left? 7 3s are 21 by 5 2s are 10. Okay, it means this 441 by 100 square root we got, that is 21 by 10, but we wanted to find actually 4.41. Now let me convert this fraction to the decimal. Here numerator whatever it is there, no, first you write down 0 1 0, and in here in place here it is 1 in between digit. Okay, that we got 2.1 is the square root of 4.41. Example number 7. A man plants his orchard with 5,625 trees and arrange them so that there are as many rows as there are trees in each row. How many rows are there? So in his orchard there are total 5,625 fruits trees which is there. Okay, and how he wanted to plant actually, if there is a 10 rows, if there is a 10 rows, in one row there will be 10 trees, like in next row there will be again 10 trees. Similarly in the all the 10 rows there will be 10 trees in each rows. Okay, that only they are saying. Arrange them so that there are as many rows are there, no, that numbers of trees only in each row. Now here we need to find that how many rows are there. We wanted to find how many rows it is there. Okay, now let's start doing a prime factorization method for 5,625. Okay, and here the number is ends with a 5, so obviously it comes in the 5's table. Okay, now 5 1s are 5, 5 1s are 1, 1 left, 5 2s are 10, 2 left, 5 5s are 25. In the next step 5 2s are 10, 1 left, 5 2s are 10, 2 left, 5 5s are 25. Okay, now 5 4s are 20, 2 left, 5 5s are 25. Okay, 5 9s are 45. Now here it is 9, so it comes in the 3's table. 3 3s are 9, 3 1s are 3. Okay, it means for 5,625 we got 5 how many times? 4 times, but I'm making a pair. I'm making it in a pair. 5 raised to the power 2 and one more 5 raised to the power 2 into 3 raised to the power 2, and its square root we wanted to find actually. Now let me take all the powers common. Okay, 2 into this square root I'm writing 1 by 2. Okay, now this 2 get cancels, so what left? 5 5 is a 25 and 25 3 is a, I'll get that is 275 we will get. Okay, sorry, it means there are 75 rows. How many rows are there? 75 rows, and in each row there are 75 trees are there. Like when you'll multiply 75 rows and each row we are having 75 trees, you will multiply like this only, no, to calculate the how many trees. When you'll multiply these two over both number, you will get that is 5625. Okay, therefore the number of rows is equals to 75. Example 8. In a basket there are 50 flowers. A man goes to worship and put as many flowers in each temple as there are temples in the city. Thus he needs 8 baskets of flowers. Find the numbers of temples in the city. See, in this question, in one basket, how many flowers are there? Total 50 numbers of flowers are there. And that man, how many baskets he need? He needs 8 baskets. See here, in one basket, it is having 50 flowers. Similarly, he need 8 baskets. So what we need to do? Multiply 8 with 50. Okay, we will get that is 400. Okay, it means he is having total 400 numbers of flowers. Okay, now see here, and he goes to worship and put as many flowers in each temple as there are temples in the city. In the city, if it is, there are imagine there are 5 temples. If there is 5 temples, in each temple, he's going to put 5 flowers. He's going to put 5 flowers in the, in a 5 temple. In each temple he's going to put 5 flowers. How are you going to calculate this? Total numbers of temples, how many there? That is 5. And in each temple he's going to put 5 numbers of flowers, that we will multiply like a 5 5 is 25. It means he's having a total numbers of flowers that is 25. But in actually he's having total number of flowers that is 400. Okay, in one basket 50 flowers. Similarly, he's having total 8 numbers of basket he needed. And if it is in each basket, if it is 50 flowers for the it means then there will be how many total numbers of flowers in 8 baskets, that we have to multiply that 8 into 50, we will get that is 400. It means now he's having a 400 numbers of flowers that he puts to the temples, and that how many temples we wanted to find. Okay, and this how we are going to find? We will find it by the prime factorization method. Now 400, start with the 2 to is a 4, 0 0 as it is. Now 2 1s are 2, 0 0 as it is. 2 5s are 10, 0. Now 2 25s are 50, 5 5s are 25, and 5 1s are 5. Okay, now the square root of 400 we wanted to find. Okay, for 400 how we got in a pair, we have to make a pairs here, like 2's pair we got, that we can write 2 raised to the power 2. Okay, now one more pair we are having, that is 2 raised to the power 2, and another we are having, that is 5 raised to the power 2. Now all the powers are same, so we can take simply common, put it in a bracket, remaining thing, and square it we can write 1 by 2. 2 get cancels. 2 2 is a 4, 5 4, 2 2 is a 4, 5 4 is a 20. It means there are total 20 numbers of, what is it is there? 20 numbers of temples, 20 numbers of 20 temple, and in each temple he is going to put 20 flowers. Total numbers of temple 20, and in each 20 flowers. So we will multiply now. After multiplying we will get that is 400. That only he had, yes or no? That is total numbers of flowers he is having, that is 400. Okay, so therefore numbers of temples which in the city is present, which is 20. Example number 9. Find the smallest perfect square number which is divisible by 8 and 12. See here, we need to find smallest, but it should be perfect square number. Okay, and that perfect square number, it should be divisible by 8 and 12. Divisible by completely means there will be remainder must be 0. There is no any remainder other than 0. Okay, so that smallest perfect square number we needed to find. Okay, and when that number is dividing by 8 and 12, obviously that number will be greater than 8 and 12. Okay, first we will find it that greater number, by 8 and 12, then that number we will make it a perfect square number. Okay, so first we will do the LCM of 8 and 12. Both numbers are even numbers. Start from the 2. 2 4s are 8, 2 6s are 12. Okay, 2 2s are 4, 2 3s are 6. 2 1s are 3 as it is. Now left with the 3. 1 as it is, 3 1s are 3. Okay, now see here. 3 2s are 6, 6 2s are 12, 12 2s are 24. And here 24 is not a perfect square number, but still we can 24 we can divide by 8 and we can divide it by 12 and remainder we will get 0. But this is not a perfect square number. Okay, to make it perfect square number we have to multiply by some numbers. That which numbers we have to multiply, that let's check. Okay, now here look at this number. This is in a pair. Okay, so we are not going to take this. Here this is not, it doesn't have a pair and it doesn't have a pair. These two number we have to multiply with this 24. 3 2 is a 6. Okay, now 6 4 is a 24. 2 as it is, 2 here. 6 2 is a 12 plus 2 is 14. Okay, now is it 144, is it a perfect square number? Let's check. 144, 2 7s are 14, 2 2s are 4, 2 3s are 6, 2 left, 2 6s are 12. 2 1s are 1 left, 2 8s are 16, 2 9s are 18, 3 3s are 9, 3 1s are 3. See, all we got in the pair. Yes or no? Now take a 1 number from the pair, from this 2, and from here 3. 2 2s are 4, 4 3s are 12. Yes, 144's square root of 144, answer we will get, that is 12. Yes or no? It means this 144 the answer for this, and 144 is it exactly divisible by 8 and 12? Yes or no? Yes, it is divisible by 8 and 12. Now that also we will do the cross check for 144 whether it is divisible by 8 and 12. Yes or no? 144 divide by 8. 8 1s are 8. Subtract what left? Left 6 and 4 comes down. Now 8 8s are 64. After subtraction the remainder we got 0. It means 144 is exactly divisible by 8. And what about 12? 12 12s are 144. Yes or no? 144 divided by 12. 12 12s are only we will get, that is 144. Sorry, 4. The remainder we got, that is 0. Yes or no? Hence the smallest perfect square, that is 144, which is exactly divisible by 8 and 12. Example 10. Find the smallest perfect square number divisible by 24, 30 and 60. This question is similar to the question number 9. See here, we have wanted to find the smallest, but that number must be perfect square number. Okay, when we will find out this number, no, it number must be completely divided by 24 or 30 or a 60. It means the remainder it is going to remain a 0. Okay, now what we have to do first we have to take the LCM of this 24, 30, 60. Again, why we are taking LCM here? Because when that number is dividing by these number, means that number will be obviously greater than these numbers. Okay, so in that case we have to take the LCM of those numbers. Okay, all numbers are even numbers. Start with the 2. Okay, 2 1s are 2, 2 2s are 4. Now 2 1s are 1 left, 2 5s are 10, 2 3s are 6, 0 as it is. Okay, still we are having 2 more even numbers. 2 6 are 12, 15 as it is. 2 1s are 1 left, 2 5s are 10. Okay, now still we are having 2 3s are 6, 15 as it is. Here 15 as it is. Now let me start taking a 3, 1, 3 5s are 15, 3 5s are 15. Now we will take 5, 5 1s are 5 1s are. Okay, now this number we need to multiply. 3 5s are 15, 15 2s are 20. Sorry, 5 3s are 50, 15 2s are 30. 30 2s are 60, 60 2s are we will get, that is 180, 120. Okay, see here 120, is it divisible by 24? Yes. Is it divisible by 30? Yes. Is it divisible by 60? Yes. It means 120 is divisible by all these three numbers, but it is divisible by these numbers. But is it a perfect square? Yes or no? Is it perfect square? Let's check that, because we wanted to find that only, no, smallest perfect square. Okay, now 2 6 are 12, 0 as it is. 2 3s are 6, 0. 2 15s are 3 5s are 15, 5 1s are 1. Okay, see here we got only one pair. All the remaining numbers are in a single. Okay, what we wanted, we to make it if it is perfect square, no, all the number whatever we will get, no, that must be in a pair. But here it is not there. It means 120 is not a perfect square, but we have to make it a perfect square. How we are going to make that? See here, look at this. Here we got this is in a pair, but these numbers are in a single. These numbers we have to multiply with now 120. 5 3 is a 15, 15 2 is a 30. Okay, 120 into 30, I'll get that is 3600. Now is it a perfect now? That also we will do the cross check, yes or no, whether we have done that is correct or no. Even number start from the 2, 2 1 left, 2 9 the 16, no 2 8 the 16, sorry, 0 0 as it is. Now 2 9 the 18, 0 as it is. 2 4 the 8, 0, 2 5 the 10, 0, 2 2 is a 4, 2 2 is a 4, 1 left, 2 5 is a 10. Okay, now let me start from the 5. 5 4 is a 20, 2 left, 5 5 is a 25. Okay, 5 9 is a 45, 3 3 is a 9, 3 1 is a 3. Okay, now let me check here prime numbers whether it is in the pair or no. Here it is pair, here it is pair, and here it is pair, here it is pair. Yes, which is in the pair. So let me take a one number from each pair. 2 5 into 3, 2 2 is a 4, here 5 3 is a 15, 4 5 is a 20, 4 1 is a 4, plus 2 is 6. Okay, here square root of 3600, that is 60. It means 3600 is a perfect square number. Again, when we will find the perfect square number, no, this is the final answer actually, but whether is it a completely divide by 24, 30 and 60, that also we will check. Okay, now let me start with the 24. 3600 by 24, 24 ones are 24, what left? 2, here 1, after subtraction this, let me take 0 down. Okay, 24 5 is 120, 0 0 0. Now let me take this 0 down, further we can't do, so let me add here 0. So here 3600, it is exactly divided by 24. Why? Because the remainder we got 0. Now let me check with the 30. 3600. Okay, 30 1s are 30, what left? 6, 1 0 comes down. Okay, 32s are 60, left 0, remainder. Now take a 0 down here, let me add here, so it is also exactly divisible. Now let me take 3600 divided by 60. Okay, 60 6 the 360. Okay, after subtraction left 0, let me take this 0 down, further we can't do, let me add 0 here, so all the remainder we got here. Hence the perfect square number is, that is 3600, and it is completely divisible by these three numbers. Okay, and this is whatever I have done, this is extra for the cross check. Actually here is the last answer for this, and from the next video I'll start from the exercise 3A. Thank you.